Hello everyone, this is Sri Guru over here. Welcome back to my YouTube channel. Okay, in the previous video we have started motion in a straight line. Basically mechanics having the two branches. The first one is kinematics. In case of kinematics, it is the study of motion of the object without considering the cause of the motion. That means for what purpose it is moving, right? That study is known as kinematics. And the second one is dynamics. It is also a study of a motion, but with considering the cause of the motion, that is known as dynamics. Okay. The next one we have studied rest or motion. When we can say that the object is at a rest, or when we can say that the object is in a motion, if the object does not changing its position with respect to the time, then we can say that the object is at a rest, right? If the object is changing its position with respect to the time, then we can say that the object is in a motion, right? There are different types of motions are there, or this motion and rest are relative terms. Relative terms means object is at a rest or object is a motion. When we can say that by taking the reference point, we can say that the object is at a rest or object is in a motion, right? In the previous video only I have given the different examples to find out the positions of the object and how they are relative, and look at the third, frame of references. By using that we can say the object is at a rest or object is at a motion, right? There are three types of motions are there: one-dimensional motion, two-dimensional motion, and three-dimensional motion. Look at the first one, one-dimensional motion. One-dimensional motion means if the object is moving in a straight line, changing its position in a straight line, that type of motion is known as one-dimensional motion. To find out the position of that object, we require only one coordinate system. That is, frame of reference is only one coordinate system, right? If the object is moving in a plane randomly, or if it is moving in a circular path, that is two-dimensional motion, right? To specify the position of that object which is moving in a circular path, we require two coordinate system, x, y coordinate. Okay. Similarly, if the object is flying inside the room, then we require to find out the position of that flying object. Three coordinate system is required, that is three-dimensional motion. Okay. And we have also discussed about the distance and displacement. Before going to that, also we have discussed about the scalars and vectors. Scalars means if the physical quantity having only the magnitude value, right? Such type of physical quantity is known as a scalar quantities, and there are some physical quantities are there which are having both magnitude as well as their direction. Such type of physical quantity is known as a vector quantity. And in that also we have discussed about the displacement and distance, right? Look at one more time in detail of the distance and displacement. Okay, now distance. In the previous video only we have discussed about the distance and displacement. But anyhow, look at one more time what is the major difference between the distance and displacement. Displacement, right? This distance is nothing but only a path length, right? And this displacement is nothing but it is the shortest distance between initial and final point, right? It is the shortest distance between initial and the final point. How we can know that? Let us consider there is a boy. He is at home. He is at home initially, right? And there is another school is there. School is at here, and there is a shop which is at here. Shop, correct? If this boy directly go to the school and next he goes to the shop, then the path length is nothing but this person traveled from home to school next to shop. This is the total length. This is what we call distance, correct? But displacement is nothing but it is only the distance between what? Initial point and the final point. This distance, this is the total displacement of this person, right? From home to shop. This is what? Displacement. Displacement. Is it right? This is the difference between path length and the shortest distance, correct? Remember, if a person goes to school and next goes to the shop, this is the total path length covered by the person is known as distance, right? But displacement is nothing but it is directly the distance from displacement from home to shop. This is what we call displacement, correct? By using this, we can define some more terms, or we can learn some more things about distance and displacement. Distance is always measured in terms of meter, and displacement is also measured in terms of meter only, correct? Now, the dimensions of distance is L. Similarly, the dimensions of displacement is also L only, correct? This path length, it may be 0 or it may be positive, but it cannot be a negative. It cannot be negative. Negative, it is not possible. But in case of displacement, it may be 0 or it may be positive or it may be negative. Now see here, path length. If the person starts from this point and it travels through a circle of radius r. Travels through a circle of radius r. The total path length of this person traveled through a circle of the radius r is 2 pi r. 2 pi r is the circumference of the circle through which this person is traveled. That is positive value, correct? If it does not travel, it stay here only, the path length covered by this person is 0, but it cannot be negative. But look at the displacement. If a person starts from here and it covers a total distance of the circumference of this circle and comes back to the same point, the initial point and the final point of the person is the same, correct? Therefore, if you take the difference, initial point minus final point, final point minus initial point, which gives 0 value, correct? Is it right? Right? 0 value. It may be a positive also. If the person is traveling in a straight line along the positive x-axis, positive x-axis. This is 1, this is the origin 1, and this is 2, and this is 3. Then the displacement of this person, 3 minus 0, 3 meter, or 2 minus 0, that gives 2 meter, right? This is always positive, correct? Then how it can be negative? If the person is traveling along the negative x-axis, minus 1, minus 2, minus 3, then the displacement is negative, correct? Is it right? Therefore, distance can be a 0 or positive, but it does not be a negative. But in case of displacement, it may be 0 or positive or negative. One more thing, remember here, always distance either it is equal to displacement or distance is greater than displacement. Greater than displacement. Either distance is equal to displacement or distance is greater than displacement. By observing these two examples, we can understand the concept of how they are equal or how they are distance is greater than displacement, right? These are the difference between distance and displacement. Okay, note down all this. Next term, speed. Speed. Have you seen the speedometer? Yes. In which the vehicle the speedometer is attached, right? Which gives how much the speed of that vehicle, right? Speed is a scalar quantity, remember. Speed is a scalar quantity, correct? And how we can define speed? Speed can be defined as, it is a just ratio of total distance covered by the object in a total time taken that object. This is a speed. It is a total distance covered by the object in a given interval of time, or the total time taken by that object is a speed, correct? Speed SI unit is meter per second. This is the SI unit, or if you want to express this in a CGS system, then it is centimeter per second. Or if you want to convert this centimeter to meter, just multiply this with a 10 raised to minus 2. That's it. Then it will give meter per second. Correct? Next. You will get all the definitions in a book or any reference books. Okay? Now see here, there are another two terms I have written here. Look at here the first one. It is the just speed is nothing but the total path length divided by time taken. Total or distance, or you can also write this as a total path length covered divided by time taken by that object, that is speed, and its SI unit is what? Meter per second. Then what is the dimensions of speed? L t raised to minus 1. Okay. Now there are different types of speeds are there. In that, the first one is uniform speed. Here I have written the definition. If the object, it covers equal distance in a equal interval of time, that is known as uniform speed. That means if the object is traveling in a straight line, the object is traveling in a straight line, and this is its initial position O, correct? And this is the first 1 meter, and this is a second meter, and this is a third meter, and this one is a fourth meter, like this. If object to cover from 1 meter, it takes 1 second only. In the second distance from 1 to 2, it takes only 1 second. And the third meter, it covers in 1 second. And fourth meter is also covered in 1 second only. Then the speed, that is how we can define the total path length divided by time taken, correct? Then it is 1 meter divided by 1 second for the first interval, then it gives 1 meter per second. Similarly, for the second distance, this from 1 meter to second meter, it takes, take the difference from here to here, 2 minus 1 meter, divided by how much time takes to cover this second meter. It is 1 second. This is 1 second, and here also it is 1 meter per second. Similarly, for the third also it is 1 meter per second. Fourth also 1 meter second. 1 meter per second. All the 1 meter is covered in 1 second. Such speed of the object is known as uniform speed. Uniform speed. Here I have taken a straight line. Okay. Not necessary that always the speed is like in a random path length. Okay. Next, remember, next one is a variable speed. Variable, if it covers equal distance in a unequal interval of time. Unequal interval of time. For that, let us consider the object is moving in a direction, along one direction, right? And it is the origin. This is 1 meter, this is 2 meter, and this one is 3 meter, and this one is 4 meter. Okay, correct? Initially, if the object to cover from 0 to 1 meter, it takes 4 seconds. For the second meter, it takes 3 seconds. In the third meter, it takes 2 seconds. And fourth meter to cover, it takes 4 seconds. Then the first, to cover the first meter, what is the speed of that object? Simply it is 1 meter divided by 4 seconds, that is 1 divided by 4 meter per second. This is the first speed when it covers from 0 to 1 meter. Look at the second distance, second meter, it covers 1 meter only, but It takes the 3 seconds to cover that distance. 3 seconds, that is 1 by 3 meter per second. Right? Similarly, look at the third one. It covers 1 meter only from here to here, but it takes 2 seconds. 2 seconds, that is 1 divided by 2 meter per second. Look at the last one. It covers 1 meter only, but it takes 4 seconds. 4 seconds. Then it is 1 divided by 4 meter per second. This speed and this speed are same, but when it is moving from here to here, the speed of the object is get changed. Right? When it covers from here to here, the speed of the object is changed. Therefore, these three are variable speed, but these two are uniform speed. Correct? These two are uniform. The first meter and the last meter is a uniform speed, but in between this from 1 to 2, 2 to 3, like that, the speed is go on changing. That change in the speed is known as variable speed. Correct? Is it right? Note down all these points. The next concept is average speed. Average speed. Average speed how we can define this average speed? Average speed, it is the total distance covered divided by total time taken. Average speed. Right? As we studied in the previous case, variable speed, when the object is traveling with a different speeds, then we require a constant speed throughout that path length covered by that object. That constant speed is known as the average speed. ಹಾಗಾದ್ರೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಬೇರೆ ಬೇರೆ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಒಂದ್ ಕಡೆಯಿಂದ ಇನ್ನೊಂದು ಕಡೆ ಟ್ರಾವೆಲ್ ಆಗ್ಲಿಕ್ಕೆ. ಹಾಗಾದ್ರೆ ಅದ್ರದ್ದು ಅವರೇಜ್ ಎಷ್ಟು? ಅವರೇಜ್ ಅಂದಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? ಟೋಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಟೋಟಲ್ ಟೈಮ್ ಟೇಕನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಕರೆಕ್ಟ್? ಫಸ್ಟ್ ನೋಟ್ ಡೌನ್ ದಿಸ್ ಪಾಯಿಂಟ್. Now see, let a different distance is traveled with a different speeds, right? That distance I will represent this as S1, S2, S3 are the distances. These distances are covered with a different speeds V1, V2, V3, so on respectively. Okay, is it right? What is the total distance traveled? Total distance traveled, that is S1 plus S2 plus S3, so on. Is it right? That the final distance is, I will take it as a ES. Correct? What is the total time taken? Total time. Whether the time is given? No. But how we can represent or how we can count the time? velocity is nothing but, or a speed is nothing but path length divided by time. Time is equals to time. If you take this time to left side and speed, this goes to denominator, right? And these are representing the speeds. Okay, this is just path length. This is path length divided by this speed, which gives the total time. Correct? That is S1 divided by V1 plus S2 divided by V2 plus S3 divided by V3 plus so on Sn divided by Vn. Now substitute these two values into this equation. Then A average speed AV, just I will represent this as AV. The total distance is what? S1 plus S2 plus S3 plus so on Sn, whole divided by what? S1 divided by V1, S2 divided by V2 plus S3 divided by V3 plus so on plus Sn divided by Vn. Correct? Is it right? Note on this or take the snapshot. Okay, note on this first. If this S1 is equal to S2, only the object is covering the two distances S1 and S2 and both are equal to S. Then what should be this equation? Then speed, average speed of that object, S1 plus S2 divided by S1 divided by V1 plus S2 divided by V2. That S plus S divided by S divided by V1 plus S divided by V2. Correct? Or S plus S is 2S whole divided by, take S common, 1 divided by V1 plus 1 divided by V2. Correct? Yes, get cancel. Only average speed is just 2V1 V2 divided by V1 plus V2. If you simplify this by cross multiplying V2 plus V1 divided by V1 plus V2, this V1 plus V2 goes to numerator, that is 2 into V1 plus V2, V1 V2 divided by V1 plus V2. This is the average speed. This is how we can calculate. Note on this. Now let consider a particle is or some object is traveling with a speed of V1, V2, V3, so on Vn in a given interval of time. With a different interval of time, these velocities, these speeds are covers in a time interval t1, t2, t3, so on tn. Now we want to calculate the average speed of this concept, right? Then V average speed, which is nothing but the total path length covered divided by total time taken, correct? Then this average, what is the total path length? Here the only speeds are given, velocity into time, which gives the path length. The first velocity is covered in a time t1, therefore we can take this v1 into t1, correct? Plus for the second path length, v2 into, it covers in a time interval of t2, v2 into t2, plus third path length with a speed of v3, it covers in a time t3, v3 into t3, plus so on, plus the last speed is vn, it covers in a time interval of tn, correct? This divided by, what is the total time taken? t1 plus t2 plus t3 plus so on plus tn. Is it right? If this all t1, t2, t3, all these are equal interval of time, that is t1 is equals to t2 is equals to t3 is equals to so on is equals to t only. All these time intervals are t only. Then we average speed v1 plus all this t become common, take it outside from the bracket t. What are the remaining terms? v1 plus v2 plus v3 plus so on vn whole divided by t plus t plus t plus t plus t. That means n times of t. N times of t. This t get cancelled. This v average is just v1 plus v2 plus v3 plus so on plus vn whole divided by n. This is the average speed. When we have to use that formula and this formula, when we study the problems, we come to know. Okay? Right? In the next video, we are going to solve some numericals based on this average speed. Okay? Thank you for watching my video. Don't forget to like and share. Okay? Thank you.